Hi, I'm David Bolton of Go Parallel, and today I'm going to talk about functional programming in Python. Now you probably know that Python is not a pure functional programming language like, say, Haskell. Python does support functional programming though, as well as object-oriented and procedural, and that's what we're going to look at. Here's an example that I found on Stack Overflow. It's basically the factorial calculation. The main function is fact. That's here, and this recursively multiplies itself by fact n minus 1. It's a standard way of working out the factorial of any number. What's particularly functional though about this example is the function tracer, which is this one here, and that contains the function traced. And the idea of this is you pass in a function into it and then call the function. So you can see here, this is where we call tracer, and having assign the value of the function call to new fact, we then call that, and in fact I'm going to change this to 6, and then I'll save that and then run that, and let's just see what that comes back with. And before calling function fact blah blah blah, afterwards got 720, which is 6 factorial. Just to be clear, because this can be quite confusing, the fact that we've got tracer function and then within that we have traced function. This is traced. What happens is when we call new fact equals trace of fact, it actually returns traced, so that when we go new fact, it's actually calling traced and it returns the result, which comes from calling the function which is passed in here, and in this case we pass it in fact, so that's how fact gets called. Now let's have a quick look at iterators. An iterator gives you access to the contents of a container. That could be a set, a list, or a dictionary. The point is you don't have to worry about the type of set. The iterator handles the details for you behind the scenes. You can even iterate over the characters of a string, as this example that I've got here does, and it starts off by creating a list, then iterating through the list and printing the values, then assigns the string value to Go Parallel, and then it iterates through the string. If we run this, well, I've done it here, so you can see 1, 2, 4, Go Parallel. One of the earliest features in Python, borrowed from Lisp, a language about list processing, is list comprehensions. It's about creating a new list with elements being the result of an operation applied to another sequence or iterable. And an iterable is an object that can return its members one at a time. We'll see this in a second. The example creates a list by taking the numbers 0 to 7, or range 8, doubling them and then adding them on to the end of a list. We can turn this into a list comprehension with a single line definition. So we'll look at the non-comprehension version first, that's here. And if I run that, we get Python 3 non-comp, we get the output 0, 2, 4, 6, 8, 10, 12, 14. That's the numbers 0 to 7 doubled. Now that's that doesn't use a list comprehension. But if we switch to the comprehension version, as you can see, it's a lot shorter. Everything within these square brackets. And what it's saying is doubles, that's the name of the array, is equal to x plus x for every x in the range 8, which is the value 0 to 7. So if we run that python comp.py, you can see we've got exactly the same output as the non-comp version, but it's a lot shorter and a lot more elegant. List comprehensions is a Python feature, and to be a good Python programmer you definitely have to know them. Generators are similar to list comprehensions, but without the square brackets. And when I say generator, I mean a generator object. There are generator functions which return a generator object, and generator expressions which evaluate to a generator object. Anyway, here's an example of a generator that prints the sum of the squares of the numbers 0 to 99, and the actual generator bit is this bit within the sum brackets, and that's I times I for I in range 100. And if we print the sum of that, and you can see I've done it a couple of times, that's 328,350, and if you work out the sum of, well, 1 to 99 squared, 1, 4, 9, etc., and add them up, you get that value. There's a bit more to generators though. They're lazily evaluated, so that if you have a function that might have generate a million numbers, it'll only generate them as you need them. If you call it, say, with 10 numbers, it'll only generate those 10 as you need them. In the example here we have a generator function called squares, and this has a start and end value, and also we pass in the name of a function, and this goes through the range start to end and calls this function, and it does this every time. Now if we call it from within a function like sum or list, as I have done here, it'll repeatedly call this until it's gone through complete from start to end. And remember, being arranged, it's from start to end minus 1. So here we have 1 and 3, we're calling isq plus 1. This returns I squared plus 1. So this will do it for 1, and then it'll do it for 2. It won't do it for 3. So it'll take 1, square it, which is 1, and add 1, so that gives you 2, and then it'll do 2 square it, which gives you 4, and add 1 gives you 5. So the two numbers are 2 and 5, and he adds them up and he gets 7. I've called list here so you can actually see the same values, and if we look here, I'll just run this, we've got 7, and there's the two values, 2 and 5. The third line here is a little bit different. Instead of calling isq plus 1, it's using a lambda function. That's an anonymous function. So what's happening here is it goes from 1 to, well, 9, but for each value, it just multiplies it by 3. So you get 3, 6, 9, 12, and so up to 27. And that's generators for you. I've tried to show some of the functional aspects of Python. They can increase your program's robustness, which is never a bad thing. Thank you for watching. I'm David Bolton of Go Parallel.